So hi there. So what have I got? Well, I've got a Lego rack and pinion. Here's the pinion attached onto this cheapo motor just by putting a screw through and fastening it on. Cheapo motor fastened onto Lego bricks so it connects onto the base plates. And the rack here made up of 3 Lego racks mounted onto a brick that will slide backwards and forwards. What I want it to do is to reciprocate, go backwards and forwards, touch this micro switch, and then go backwards, touch this macro switch, and then go in the opposite direction. And if I switch it on, it's quite happy going backwards and forwards. A quick zap as to how it's done. It uses a motor and the 2 micro switches, the 2 changeover contacts on the thing called a relay. So that's my relay there. Can we see the contacts on the inside here? So those are the contacts that change over, and that's the coil on the relay. So that's the coil on the relay. That's the micro switch which is normally open, which is this one, and the one at the other end is what we call normally closed. This can't be switched off without disconnecting the power, but as it is there, when I switch it on, the top of the motor then connects to positive, the bottom of the motor connects to negative, and it goes along until it hits this normally open switch. When this is closed, then a little current flows through the coil down to the bottom. That energizes the relay. The top then becomes negative and the bottom becomes positive, and therefore it changes direction. I want it to stay going in that direction, so when this is positive, it supplies a current to this diode, which then supplies a current into the top of the coil and keeps the coil energized without needing this switch. So this switch can open, but the coil's still energized because it's getting its energy from this switch round here through the diode and into there. And that then keeps going until it hits this switch at the other side. But I don't want to do that. I don't want an electronic solution. I would like a mechanical solution, which is going to involve in some way changing the direction of the motor, of the output, without changing the direction of the motor. So to do this, I've used 4 gears. It's difficult to see this little pinion under here, but that drives this gear, and this gear then is on a shaft which can move from place to place. So when it's in, let's move it to that position, and I turn the input. This will be on a motor. I turn it anti-clockwise. We can see that this output shaft here also turns anti-clockwise, because it's turned, if I can hold it correctly, because it's turned by the idler gear. This gear in the middle is an idler gear. This gear here isn't doing anything when it's in that position. But if I move across to this position, and now I turn my input anti-clockwise, we find that the output gear goes clockwise. So these 2 gears act as idler gears to change the direction. So if this one's going anti-clockwise, this one goes clockwise, this one goes anti-clockwise, so this one goes clockwise. So there we go, and there they go, zooming round. So if I can move the position of the lever, I can change the direction in which the out model works. So Oh, and there is one important point about this that makes it difficult to build, and that is essentially the drive is in the centre, so it will be on the same as that hole there, but the gears need to be offset. To do that in this particular case, I've just used bricks with 2 holes in. That offsets the gears and makes them above there. This is a difficult sort of thing to do. You can do it in several different ways. We can do it just using technical bricks. Technical bricks are clever. The studs on the top have holes in, so not only can that go in line along there, that's in line, but I can move it across and the little studs sticking down go into the holes in the studs at the top, and that then once again moves this shaft relative to these two. So that's one technique of doing it. Of course, I can't put a smaller brick on top of a large brick, because if I try to do it that way, then the edges of the brick catch on the studs and it won't work. So it's got to be a smaller brick underneath, not in that position, but in that position, so that this hole is offset to those two. So that's how I've done that. So here's one of my early attempts to do this. Oopsie. If we look at this, what we got is, let's move everything out of the way. What we've got is 2 larger wheels here, similar sort of idea. It's got a Lego motor on this one actually, which is good. Lego motor, 2 gears like I had on the other one. This arm then is the arm that's going to move from side to side. There's a gear on the motor and an idler gear there that will swap between these 2 larger gears. We can put this together, turn it round. What I have got is a long arm. Can I see the long arm? Oops, that's a bit too much. There's my long arm, which will go from side to side. So hopefully this long arm is going to be pushed by these 2 pieces. So they come along, push it across, it goes across, this one comes back and pushes it back again. So let's try it. The idea being that it won't be stable when it's in the middle, but will fall to one side and hopefully will be pushed across. So there it is going across, that pushes it across, goes to that side, and this one pushes it the other way. So this is the mechanism we've seen, but there we have the problem. It gets to halfway and it doesn't fall across. It takes very little effort to move it, but it does balance for some reason. Normally it'll go across, but often just balances in the middle like that, and so therefore is a failure. It sometimes works, but is very delicate as a system. It is balanced again, so not too good. We need to move on. What can we move on to? Well, let's try moving can I get it without it falling apart? Yep, I think so. Move on to this one, which uses the same sort of principle for reversing. The 2 gears in this case, I don't know if we can see well, that are joined together at the bottom here. The idler gear that's on the arm is here, and the output from the motor is here. But so that it can operate, what we done, move that out of the way. we've put a gearbox on the top, so that the arm is driven by this lever here, which in turn comes from this cam, and this cam is driven from this large gear here, which in turn is driven by the pinion at this side, and then we have another large gear which is driven straight from the motor. So the motor drives this little pinion and this gear on the end, and as this goes round, this moves the motor, moves the output lever from side to side. So will it work? Let's plug it in and try and see what happens. So can we see that? I think we can. Do we need to be a bit bigger? Oh, is that a bit better? Try moving the camera a little bit and come down a bit. There we are. Right, so if we move this, oops, keep the wire out of the way, moves across, and after a while moves back again, moving across and back again. If we look behind, we can see the lever here being moved backwards and forwards by this, well, it's a gear but it's acting as a cam, moving that backwards and forwards, so the whole thing moves backwards and forwards. But it has a problem. It moves further in one direction than it does in the other, and the direction that it is moved is set by the gearbox. So if I wanted to put end stops on so it came all the way to the end, be a difficult job to design a gearbox that was exactly that size. So yeah, I like that, but isn't really what I'm looking for. So let's move on. Where are we going to next? Well, next we need a system that what? Let's have a look what we got. So what we have now is a system with a toggle switch on. A toggle switch. The idea being that the switch moves quite a long way before it actually moves the lever arm. So let's try it to start with. Oopsie, that's broken it. Move the wire out of the way and let's see what happens. That's going that way, that seems good. Comes across, operates the toggle switch, which operates it, and then this comes back. Oh dear, it's failed. Has it? That's worked. And that's worked. And that's worked. And that's worked. So what's happening here? Here we have this toggle switch, which is based upon two studless arms with an elastic band between the two, and when this is pushed, the elastic band stretches and stretches until need to move the end stop out the way. Can't do it, so let's move it using this. Right, I move the end stop here out of the way, so now when I push the bottom of the toggle across, it goes quite a long way until it gets to that point there. When it clicks across, it still hit the end stop. Oopsie. So it's toggled it across, pulling this up across here, and then the arm that's got the gears on it is hidden here, and we have a parallelogram so that the toggle switch is operated from this side by this lever, which pushes the rod, which then pushes this lever at this end, and it goes across and snaps across backwards and forwards. Behind then we can see we've got one of the two gears that are connected together there. Can't see, well, we can just about see the other one there, and then we can see the idler gear here, and of course we have the pinion on the top of the motor. So there we have a reciprocating motion that does what I want it to do. So will it do it? Go on, go on, yeah. So the end stop comes across, presses onto there, pushes the mechanism across, changing direction, going backwards and forwards. But is the crash gearbox a good idea? Not too sure. Seems a bit big and bumbly. Don't know if I could make it smaller, but I think I'll have a go. So yeah, there's my mechanism doing what I wanted it to do using a toggle switch. Why my original won't work with weights, when it gets to the middle, why it doesn't fall over, not too sure, but that certainly overcomes the problem. Yeah, I like that. Oh, do like it. Right then, so it's bye now. Bye.